Hey there! Today, Shashi wants to share something he learnt with you. You might think this is odd, but Shashi learned something from a spanner. How? Well, he had to tighten a nut on his cupboard with the help of a spanner. It had a long handle, but there was some sticky dirt at the end of its handle. So, he held the spanner in the middle and tried to tighten the nut. But guess what? It took a huge effort to rotate the spanner. But when he tried to tighten the nut by holding the end of the spanner, it was very easy. Why does it become easy when you hold the spanner at the end and not somewhere in the middle? Shashi wondered. For the same nut, he tried many positions where he could apply force and check if the spanner rotated or not. He observed that the closer you go to the nut, the more difficult it gets. If you move away and apply force from a distance, it becomes easier. In this case, the force is expected to result in the spanner and the nut rotating. The rotational effect of a force is called torque. Torque obviously increases if you apply more force. But if you did apply more force, the door of the cupboard would get banged because the torque is greater and rotations are far more and faster. But that is not all. Watch Shashi apply force perpendicular to the length of the spanner. The perpendicular distance between the force and the axis of rotation is very significant. This perpendicular distance is called moment arm, which literally means the arm for the moment. Torque is equal to the product of force and moment arm. To produce the rotation of this nut, a fixed amount of torque is needed. If you hold the spanner closer to the nut, the moment arm is less and you'll need a lot of force. If you hold it at the end, the moment arm is greater and a little force can do the job. Torque, therefore, is equal to force into moment arm. This is how a spanner and a nut taught Shashi such an awesome lesson in physics. See you next time.